Hello everyone, welcome back to this lecture series on engineering mechanics. In the previous lecture, we solved numerical problems on concurrent force systems using free body diagram concept, resolution of forces as well as equilibrium equations applications. In today's lecture, we'll continue with the more advanced applications where the problems in which the geometry plays a key role and the forces may act at a point of impending motion where careful interpretation of free body diagrams is essential. So this is problem number 4. A uniform wheel 40 cm in diameter rests against a rigid rectangular block 10 cm thick as shown in figure. Find the least pull through the top edge of the wheel to just turn it over the corner of the block. All surfaces are smooth and the wheel weighs 800 Newton. So it's been given a wheel is being given, right, and a block is being placed near to the wheel. So the wheel is in contact with the block. So as per the given problem, we are supposed to apply the external force in order to make this wheel to roll over this block at the top end of the wheel. So this is what is the condition. So at the point C, we are applying a horizontal force P, where O is the center of the wheel and A is the point where it is having the contact with the block. So the data what have been given is the diameter of the wheel, which is 40 centimeter, thereby radius will be 20 centimeter. The thickness of the block is 10 centimeter, weight of the wheel will be 800 Newton. And they clearly mention all surfaces are smooth. Let us first understand the physical meaning of the problem. So here the wheel is about to rotate over the corner of the block. At this instant, the wheel loses contact with the ground. So it is about to lift. When it is having the contact, once additional force has been applied, it is about to roll over the block. At that particular instant, there won't be any contact at this ground level. So the wheel tends to rotate about the point C because here the force, external force has been applied at the point C. Therefore, the wheel tends to rotate about the point C. So therefore, the point C becomes the instantaneous center of rotation. So this observation is crucial for solving the problem. Let us go with the free body diagram. The forces acting on the wheel will be, the weight will be W is equal to 800 Newton, which will be acting vertically downward at the center point. We have a pull P, which is applied horizontally at the top edge of the wheel. And the normal reaction which will be generated from the block, and it will be directed towards the point where the external force is being applied, because this is the point which is the instantaneous center of rotation since the external force has been applied at this point. Since all the surfaces are smooth, there is no friction. Now, so we need to find the inclination of this normal force. So for which we are assuming that inclination of the normal force with respect to the vertical as theta. So we need to find this theta. So in order to solve for this theta, let us establish a geometry. So creating a triangle ACB and one more triangle with respect to the point O, that is OAB. And we know that the radius or the diameter of the wheel is being given as 40 centimeter. So the diameter is given as a 40 centimeter and the radius from O to C will be 20 centimeter. But our question is we need to find O to B. Then only we can able to find out any of this side. So O to B we need to find out. So total is 40 centimeter and this one is the height of the block. So this is 10 centimeter. So this is 10 centimeter. So if this is 10 centimeter and the total height is 40 centimeter, so this is 40 centimeter. So the remaining will be, and obviously this is the radius. This is 20 centimeter. So I need the value OB only. So the remaining will be, total is 20 and then 40 minus 20 minus 10, it will become 10 centimeter. So OB will be equal to 10 centimeter. Right, so once OB is known, we need to know one more side in order to find the included angle, or even we can able to find out this side AB. So in this case, OA represents the radius of the wheel that is being given, that is 20 centimeter. So now two sides of this triangle OAB is known. So from which the third side can be calculated by using the Pythagoras theorem. So from triangle OAB, AB will be equal to root under OA square minus OB square. So in which OA is known 20 centimeter and OB is known 10 centimeter, from which AB can be found out as 17.32. So this distance is known, that is 17.32. So once this distance is known, considering this triangle, because I need to calculate this angle theta. So if I am considering this triangle, this side is known, that is AB is known. And also we already calculated the value BC, which is nothing like total diameter 40 minus the height of the block 10 centimeter, which comes 30 centimeter. So now two sides of this triangle is known, from which the theta can be calculated. So that is what from triangle ACB, tan theta will be equal to AB by CB, where AB is the distance 17.32 just now we calculated, and CB is the total height deducted from the height of the block. So that is 40 minus 10, you will get 30. So substituting that value, you will be getting the theta as 30 degree. So now if I am drawing the free body diagram for this block, taking away all the forces separately, you can see that P is acting horizontally and weight is acting vertically downwards, and this normal reaction which makes an angle theta with respect to the vertical. This is what is the angle theta. So once if these values are known, let me erase these things. Now you can see that if I am going with this free body diagram, so we have three forces are there, in which weight is known, P and N are the unknowns, in which P is the one which has been asked to solve. Right. So let us write the equilibrium equations. Fx equal to 0 in the sense we have P which is acting horizontal in the left side direction, which will become negative P minus P. And N is an inclined force, so which will have the components both in the x direction as well as in the y direction. So a horizontal component will be acting in this direction, vertical component will be acting in the vertically upward direction. So a horizontal component is acting towards the positive side, which means the positive will be the horizontal component for this N. Now you can see that N inclination has been given with respect to the vertical. So in that case I need to find the horizontal component, means the horizontal component will be sine theta. So that is why it has been given as N sine 30 degree minus P equal to 0. Let it be equation number 1. Next we shall go with the vertical force equilibrium Fi equal to 0, in which P will not play any role, because P is a truly horizontal force which will not have any component with respect to the vertical axis. So now this W is acting vertically downwards, so this value will be negative minus W. Now again going on with the component of this normal reaction with respect to the vertical axis, you can see the force resolution will be acting in the upward direction, so that will be positive. And again the angle is given with respect to the vertical, so vertical component of this N will be cos theta. So that is why N cos 30 minus W equal to 0. Since W is known, which has been given as 800 Newton, so we have only two unknowns. One is N and the other one is P. So we have two simultaneous equations with the two unknowns. Solving these two equations, we can get the value of this N as well as P. So we are getting the P value as 461.88 Newton. And this is the least pull required to just turn the wheel over the block. This is a conventional problem most of the examinations it has been asked. And one more thing is that it's not like only this one, even we have one more cases available. Rather than the applied force is acting at the top of the wheel, sometimes the force may be acting at the center of the wheel also. So if we have one more condition is also available. So in this case, what is the differences? There is no change in the direction of the forces, both being applied in order to make the block towards left side direction. Right? The point of application differs. In the first case, the externally applied forces being applied at the topmost point of the wheel, whereas in this case the applied force is being acting at the center of the wheel at point O. So that is the two difference. So once if the force is being applied, both the cases, the wheel will tends to roll over the block. So one difference what we can observe in both the cases is, since the external force is being applied here at the topmost point of the wheel, this point will becomes the instantaneous center of rotation. Whereas going on with this case, the external force is being applied at the center. Don't worry whether it is applied vertically or horizontally or an incline, that doesn't matter. The force is being applied at the center. So in the second case, the point O will becomes the instantaneous center of rotation for this wheel. So since the point C is the instantaneous rotation, for this condition, the normal reaction from the block is being pointed towards that point. Whereas in this case, the point of rotation or the center of rotation is acting at the point O. Therefore, the reaction from the block will point towards the O. So that is what has been given. So that is the only difference between these two cases. So once if you know this simple concept where that instantaneous center of rotation will be taking place with respect to that point only, then reaction from the contact points will be directed. If you know this one, later resolution of forces applying the equilibrium equations, we can able to solve for the unknowns. Next, problem number 5, in which you can see the extremities A and D of a light inextensible string ABCD are tied to 2 points in the same horizontal line. So weights W and 3W are tied to the string at points B and C respectively. If AB and CD are inclined to the vertical at an angle of 60 degree and 30 degree respectively, show that BC is horizontal and find the tensions in the various parts of the string. So here we have the strings A and D, both are lying at the same horizontal level. So intermediately, two weights being suspended at point B as well as point C. The weights being given as W and 3W respectively. So once the weights being suspended, the thread portion or the string will become in the form of a straight lines with different contact points. We have three different portions, AB, BC and CD. Wherein AB portion is having an inclination of 60 degree with the vertical and CD portion will have a inclination of 30 degree with the vertical. Whereas the question is, you need to prove that the portion BC tends to be horizontal, which is nothing like, if I am taking this as an angle theta for the portion BC with respect to vertical, if I am solving for theta, we need to get the value as 90 degree. If I am proving that 90 degree in the sense, the portion BC will tends to be in the horizontal direction. So once it has been proved, the second case is we need to solve for the tensions in all the three segments. Now let us draw the free body diagram. Now we can see that if there is no objects are available, the joints can be treated as free bodies. So here in this case we have 1, 2, 3, 4. 4 free bodies are available. Point A, point B, point C and point D. So if I am taking point A, where we'll have this support will be there, which has been connected to the roof, which means that support reaction will be coming. That is an unknown concept. And similarly at point D also, which has been connected to the wall or the roof, wherein the support reactions will be generated. Again, that is also been not known as of now. So in that case, you can consider the joint A as well as joint T as a free bodies. So in that case, we can go with either joint B or joint C or both the cases in order to solve for the unknowns. Let us start with the joint B. So if I am taking with the joint B in the sense, this joint has been connected with the two members, that is BA and BC. In addition, a weight has been suspended in the vertical direction with the value W. So that's what has been shown here. Point B, where the weight is vertically displaced. Secondly, the tension in the portion AB treated as T1 and the tension in the portion BC treated as T2. Now here the angle for the portion AB has been given as 60 degree with the vertical. That's what has been taken here. And one more thing is that we assumed this angle is theta because this is what we need to find it out. let me keep it as theta itself. So this is the free body for the point B. Now let us draw the free body for the point C. Again starts with a weight which will be acting vertically downwards. Then we have the tension in the portion CB, which is T2, and similarly the tension in the portion CD, which is T3. So the angle for the inclined portion CD has been given as 30 degree with the vertical. So we can take that one also. And since T2 is having an inclination of theta with respect to vertical, we can mark that one also. Now we have two free bodies, and how many unknowns are T1, T2, T3 as well as theta. So we have 4 unknowns will be there. So for every free bodies, since it is a two-dimensional system, we have two equilibrium equations. One is Fx equal to 0 and the other one is Fy equal to 0. So for point B, we will have two equilibrium equations. Similarly, for point C also, we will have two more equilibrium equations. So totally, we will get 4 equilibrium equations in which we have 4 unknowns. One is T1, T2, T3 as well as this theta. So 4 unknowns with the 4 equilibrium equations we can solve for the unknowns. Now let us solve this one. Let me take the first free body point B. Right. And now one more thing, you can see that it is a concurrent force system said to be in equilibrium, and we have a 3-force system and all the forces are directed outwards from the contact point. So if that is the case, we can try to solve this problem by using Lami's theorem approach rather than going on with the resolution of forces. Even you can solve by using the resolution of the forces also. So one thing, if you are going with the Lami's theorem, is we need to find the included angle between all the forces. That is the angle between T1 and T2, angle between T2 and W, as well as angle between W and T1. Unlike the way that you are doing in the resolution of forces, wherein the inclination of all the forces with respect to either x-axis or y-axis is known. Now, this is the angle which has been given. The T1 is having an inclination of 60 degree with the vertical. And one more thing is that the T2 is having an inclination of theta with respect to the vertical. So making that one, you can see this is 60 degree in the sense from this vertical to this vertical total is 180 degree. So 180 minus 60 will be getting this angle as 120. That is the angle between T1 and W. And the angle between W and T2 is theta. That is what we need to find it out. So the remaining angle between T1 and T2 is 240 minus theta. Now applying the Lami's theorem, so I will get T1 divided by sine of the angle between T2 and W, which will be equal to T2 divided by sine of the angle between T1 and W, which will be equal to W divided by sine of the angle between T1 and T2. So that's what has been applied here. T1 by sine theta, T1 by sine theta, T2 by sine 120 as well as W divided by sine 240 minus theta. So we can connect any two of these 3 conditions. Let me take T2 and W. If I am equating these two, we will be getting the value of T2 in terms of W. Now let me go with the second free body, that is a point C. Again representing the tensions, making the inclinations. It's been given 30 degree with a vertical, that T3 is having 30 degree with a vertical, and T2 is having theta with respect to vertical. So the total angle between T2 and T3 will be 30 plus theta. And from this vertical to the bottom vertical, the total angle is 180 degree and this is 30 degree. So in that case, the angle between T3 as well as 3W will be 150 degree. So the remaining angle is the angle between T2 and 3W, which comes around 180 minus theta. So again, applying the Lami's theorem, in which T2 divided by sine 150 degree, T3 will be equal to, T3 divided by sine 180 minus theta, which will be equal to 3W divided by sine 30 plus theta. So substituting these values, and again we need to equate any two conditions. So previous case we equated T2 with the W. Let me go with the same case T2 with the W. So that you'll be getting a relationship for T2 in terms of W. Let me put this one as equation number 2. Now you can see we have two equations which have been calculated for T2. So left sides for both the equations remain same. Right. So equating these two, we will be getting the only unknown as W. W will be getting cancelled. The only unknown will be theta. So equating 1 and 2, we'll be getting the theta is equal to 90 degree, which means that the portion BC is said to be in horizontal direction. That is what is the first case. So once BC is being proved to be horizontal, we are supposed to calculate the tensions in each portions. So substituting the value of theta in any of these two equations, we can able to find out the value of T1, T2 as well as T3. So I'll get T1 will be equal to 2W, T2 will be equal to root 3W as well as T3 will be equal to 2 root 3W. So to conclude today's lecture, always identify the point of impending motion. Have to draw a clear free body diagrams. If there is any string problems, apply the equilibrium at each joint considering the joints as a free body. And the geometry and trigonometry are equally important as equations. In the next lecture, we will proceed with the non-concurrent forces in plane. Thank you.